Chapter 2, Section 6, our essential question is how can you use base 10 blocks to model decimal division? And you did some of that yesterday in the activities. Again, in this section we have the key idea, dividing decimals by whole numbers. You need to write down the words, place the decimal point in the quotient, above the decimal point in the dividend, then divide as you would with whole numbers. Continue until there is no remainder. And if you will notice, it says place the decimal point in the quotient, and this is your quotient is answer, above the decimal place in the dividend. So it goes straight up. Quotient, dividend, divisor. Go ahead and pause and come back when you've written the note. Example 1. We need to find 7.6 divided by 4. Once again, notice the estimation. Everything can be estimated. In this section, everything with what we're working on can be estimated. So we did 7.6 divided by 4. The very first thing they did was move that decimal point up. If you do that first, you'll be good. So now you do regular division. How many times does 4 go into 7? Okay, it goes in once. Minus 4, 3. How many times does 4 go into 3? It doesn't. So you're bringing down the 6, which is on the right side of the decimal point. Now you have 36. So how many times does 4 go into 36 is 9. Once again, is this reasonable? Yes. B, the next example they're giving you is 4.38 divided by 12. So here we have 4.38 divided by 12. They brought it all the way down. They used the 4, they used the 3, and they used the 8. Okay? 12 into 4, that doesn't work. 12 into 43 works. That's 3. Now because you went into a number that's to the right of the decimal, you need to make sure your answer is to the right of the decimal. Once you did 3 times 12, you can subtract out the 36. Leaves you with 7. You bring down the 8. Then you ask, how many times does 12 go into 78? The answer is 6 times. Subtract 78 and 72. Now remember, in our key points, you have to keep dividing until you have no remainder. So you bring in a 0, because we can add as many zeros as we want to the right of the decimal as long as it's past all our regular numbers. It doesn't matter. It doesn't change the number. So you're going to bring the 0 down, which you've added, and that makes it 60, and you can take it to 0. Alright? Reference this if you need to in doing the on your own number 1 through 6. Show your work. Come back when you're done. The next part we're going to look at is dividing decimals by decimals. Here you multiply the divisor and the dividend by a power of 10 to make the divisor a whole number. Then place the decimal point in the quotient and divide as you would with whole numbers. Continue until there's no remainder. This sounds confusing. It is a little bit. So if you would just write your notes and we'll refer back to them and then come back when you're done. Alright. Let's take a look at these numbers. First I want you to look at the study tip for example 2. We're going to look at that example. Multiplying the divisor and the dividend by the power of 10 does not change the quotient. In other words, 18.2 divided by 1.4 is 13. Also 182 divided by 14 is 13. And 1,820 divided by 140 is 13. So although we've changed things around a little bit when we're working with division, just because we move a decimal point, it's okay because it'll come out to the same answer. So let's take a look at what our notes were talking about. We took 18.2 and we divided it by 1.4. Now, I don't want a decimal point on the outside here. My divisor should always be a whole number. So what I'm going to do is move my decimal point to the right one spot. And I'm going to do that to make it a whole number. But whatever I do on this side of the dividing line, I have to do to this side of the dividing line. So I change the decimal point to the right and make it 182. Once I divide that all out, it will come out to 13. And notice in 182 they did put a decimal point there, and you can do that to help you out, so that you understand what's happening here. And also, if it doesn't come out evenly, when you add your zeros, it'll be to the right of the decimal point. B, example B, same thing. First you look at the outside and you have 0.39 going into 0.273. On the outside, you move the decimal point 2 places to the right to make it 39. Now you don't move the inside number 3 places to the right, you only move it 2 places to the right, just like this side. This is what it's going to look like. Then you go back and you think about what we did in example 1, and we move that decimal point up to the top, exactly above. And now I can work this out again. You can check it out. And in this case, they checked it out by doing the opposite. They did this times this, and they should get this answer. And that's a great way to check it. Do the on your own 7 through 10, show all your work, and come back when you're done. Example 3. Inserting zeros in the dividend and the quotient. This one's a little trickier, but it'll make sense at the end. Take a look at this problem. It's 2.45 divided by 0.007. So once again, I have to make this a 7. I've got to move it over all these decimal places. So I moved it over 3 decimal places. If I move this over 3 decimal places, which if this is 3, this has to be 3. Just because I don't have a number doesn't mean that I can skip it. I have to put a 0 there to hold a spot for before the decimal point. So I've moved it 1 between the 4 and the 5, 2 after the 5, and then I added a 0 so I could move it 1 more time. So when I write my problem, it changes a little bit. The 2.45 changes to 2,450. And the 7, that stays the same. Now, we multiply this out. 3 times 7 is 21, leaves you with 3, bring down the 5. 5 times 7 is 35. Perfect. That should be it then, 35, right here for our answer. But it's not, because there's a 0 here. I have to use it. If it makes more sense for you to think, oh yeah, I'm dropping that down, there it is, I've got to use it. Or just think, if there's a 0 on the end, there better be a 0 on the end here. So in this one, remember, however many times you move that decimal here, you move it on this side, but you might have to do zeros to fill in spots. Do 11 and 12. Oh, sorry, 11 through 14, and show your work. Show your work and then come on back. Make sure you did show your work in this on your own that you just did. Now let's move on to example 4, or the real life application. Once again, Mrs. Kreider, when are we ever going to use this? Well, if you're going to figure out how many times more cellular phone subscribers there were in 2011 than in 1991, you will use this. It says you are going to figure that out, and you're going to round it to the nearest whole number. So here's your graph to the left, telephone subscribers. 1991, 1996, 2001, 2006, and 2011. From the graph, there were 331.59 million subscribers in 2011. And remember, we want to use that number. And 7.6 million in 1991. So, notice it doesn't say how many more subscribers, it says how many more times. So you have to divide it out, okay? How many more times, not how many more. So your estimation is here. If you look at our example, we did move the decimal point once to the left and once on the right. It leaves us with a decimal point. We raise it up and we do the calculations. But my answer is there were about 44 times more subscribers in 2011 than 1991. Please look at your wording. It does not say how many more cellular phones. That's subtraction. How many times more? And you need to use that in your answer. Okay? And it also said round to the nearest whole number, which is what they did. All right, do the on your own number 15, and I'll see you in class tomorrow.